Alright, let's look at the homework 16.7, problem number 7. Alright, so let's evaluate this surface integral here. Alright, so I already drew the solid here, and S is the surface of this solid. And you can see that there are three parts to it, and S1 is going to be the side wall of the cylinder, and S2 is the intersection with the plane x plus y equals 7. And S3 is the bottom. All right, so let's consider, look at the S1 first. So S1, all right, so the parameterization is going to be, since this is a cylinder and the radius is 1, so we can probably do something like this. So R is going to be, all right, so there's no restriction on Y value, so this is going to be just a Y by itself. Alright, then we have, let's say theta, so I'm going to do, so since x squared plus z squared is equal to 1, so I'm going to put the sine of theta and the cosine of theta. Alright, so we can do the partial of r with respect to theta, cross product with the partial of vector r with respect to y. Right? So this is going to be, right, so we have a vector I, vector j, and vector k. Right, so partial of this guy with respect to theta would be cosine of theta, 0, negative sine of theta. Partial with respect to y is going to be 0 here, and we have a 1 and a 0 there. Alright, so we get, alright, first component is this times that, so it's going to be sine of theta. The second component is going to be 0. Alright, third component is going to be simply cosine of theta. Alright, so if you want to compute this integral, so we have a double integral, right, over S1. Alright, so F is going to be, so X is going to be sine of theta. So we have, let's see, sine of theta. And the second component is Y, which is just Y. Right, then the third component is 9, so we have a 9 here. Right, then this cross product is sine of theta, comma, 0, comma, cosine of theta. Right, then we're going to have to do, let's see, let's do dy first. So we're going to have dy and then d theta. Right, so dy is going to be, let's see, it's going to actually go from 0, which is on the xc plane. So it starts from 0. Actually, I'm going to just go ahead and put the lower bound and upper bound. Alright, then this is going to go all the way to this plane x plus y equals 7. So if you solve this equation for y, you get the y is equal to 7 minus x. So y is going to go to all the way up to 7 minus x. So you're going to have 7 minus, but the x is a sine of theta. So we have a sine of theta here. Alright, then we have to go all the way around to cover the entire sidewall. So theta is going to start from 0 to 2 pi. Alright, so let's evaluate this. So this is going to be equal to, alright, so I'm going to leave the outside integral as it is for now, so 0 to 2 pi. Alright, and actually we have to do the dot product first, so I'm going to have to leave this as it is. Alright, so it's going to be sine squared of theta plus 0 plus 9 cosine of theta. right? Then we're going to do it with respect to y, and then we have a d theta, right? So if you take the antiderivative with respect to y, we get this, right? Go from 0 to 2 pi, right? So antiderivative is going to be sine squared of theta y plus 9. Actually, let's see, how do I, maybe I'll do this. All right, 9 plus a 9 cosine of theta, then times y, because this is just going to be a big constant. And then you're going from 0 to 7 minus sine of theta, right? D theta, right? So if you plug it in, right, you have from 0 to 2 pi, right? So basically we just multiply sine squared plus 9 cosine of theta times quantity 7 minus sine of theta. All right, so I'm going to just distribute 7. So you're going to get 7 sine squared of theta plus 63 cosine of theta. All right, then we have a minus sine cubed of theta, right, and a minus 9 sine of theta cosine of theta, right? So we have that with respect to theta. All right, then we just need to evaluate this integral. All right, so first thing I would do is we have to do some rewriting. All right, so we have, all right, sine squared of theta is 1/2, so it's going to be a 7/2, right? And a 1 minus cosine, so it's going to be 1 minus cosine of 2 theta, right? And plus 63 cosine, I like it as it is, so I'm going to leave it there. All right, then this one, actually, let's see what, let's see, I'm going to actually separate this. I'm going to put the minus out here. So negative sign, negative sign. Then I'm going to put the d theta here, minus, right, 0 to 2 pi. All right, I'm going to leave negative sine of theta out here. And then you have, actually, so negative is already, let's see, I'll put the plus sign here. All right, then you have a negative sine of theta pulled out, so you have a sine squared of theta plus 9 cosine of theta, right, d theta, right? Then let's evaluate this. Antiderivative of this is going to be 7/2 is just a constant, right? Antiderivative of 1 is theta. Antiderivative negative cosine of 2 theta would be negative sine of 2 theta over 2, right? Plus 63, antiderivative cosine is sine of theta. And then it's going from 0 to 2 pi, right? And here we can probably use the substitution. And since we can rewrite this guy as 1 minus cosine squared of theta, right? So I'm going to use a substitution. I'm going to let u be cosine of theta. So if you take the derivative, du over d theta is going to be negative sine of theta. Take the reciprocal of both sides, we get the 1 over minus sine of theta. So we know that the d theta is du over negative sine of theta. All right, so we can see that this is an integral from 0 to 2 pi. And I'm going to leave negative sine of theta as it is because it's going to get canceled out. All right, so this is going to be, all right, 1 minus cosine is u, so u squared, plus 9u. Right, d theta is du over negative sine of theta. Right? Then I'm going to have to actually change the binds here. Right? So cosine, so when theta goes from 0 to pi, which means that the u is going to be, plug in 0, cosine of 0 is 1. And the the cosine of 2 pi is going to be 1. Actually, it's going to go from 1 to 1, which is actually kind of nice, right? So you can see that this whole thing is going to be actually 0. So this is actually 0, right? Then we plug in 2 pi, so you're going to get 7 pi. And plug in 2 pi here, sine of 4 pi is 0. And plug in 0, plug in 0, plug in 0, it's all 0. So you just get 7 pi, right? Let's look at S2. So we have S2. Right, this one, we know that the equation is x plus y equals 7. So the R, the parameterization, is going to be, we can probably use x, and y is going to be 7 minus x. And the z could be anything, so we can use z. Right? Alright, so if you compute the partial with respect to z, cross product with the partial of r with respect to x, we will get, right, vector I, vector j, vector k. Right, partial with respect to z will be 0, 0, 1. Partial with respect to x will be 1, negative 1, 0. So this is going to give us, let's see, first component is going to be negative, negative 1, positive 1. And 1 minus 0, so it's 1. And 0 minus 0, so it's going to be 0. All right, so the integral becomes, so this is a double integral over s, right? And the f is going to be, right, x is x, right, and the y value is 7 minus x, and the z is 9, and we're going to take the dot product with 1, 1, 0, right, and the dA over, actually this is over the unit disk, so I'm going to call it D, right? Since x and z living in the unit disk to cover this region here. All right, so if you compute that, you're going to get here, so you have a double integral over D. If you multiply that, so x times 1 is x plus 7 minus x times 1 is 7 minus x, and 9 times 0 is 0, right, dA. So we can cancel x and x here. So this is going to be, if you pull out 7, right, this is just the integral of the integral over the disk of the area element, which means that this is just going to be an area of the disk D. This is a unit disk, so area is pi, so this is going to be 7 pi. Right, so that's S2. Right, S3, hopefully this is a simple one. So S3 is, let's see. So this is the easiest one because the unit vector is pointing in the negative y direction. So we know that the n normal vector is negative j. Right, so if you compute this, so you have an integral over S3, right? Then at that point, let's see, since this is on the xz plane, y value is 0. So we're going to have x, then y value is 0, it's 9, right? But normal vector is negative j, which is 0, comma, negative 1, comma, 0, right? And then ds, this is going to be just a ds, right? Then if you compute that, you see that this is integral over S3, but the integrand is just going to be 0 plus 0 plus 0. It's 0. So this surface integral is going to be 0. Right, so the answer is going to be, we have to add these guys up. So 7 pi plus 7 pi plus 0. So answer is 14 pi. All right, so let's submit. All right, so we got the here 14 pi. All right, let's check the answer. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.